Once again, welcome back to the video series on Math Revision Made Meticulous. Day 17, Evaluating Definite Integral by Substitution. Revision, as the name suggests, means looking back over previously learned information, ensuring that it is clear and fresh in the mind. 5 questions per day from selected topic is presented at this video series. The steps in answers are supported by the ideas used for getting the answer. Let f be a continuous function defined on a closed interval a b and capital F be the antiderivative. Then integral a to b f of x dx is f of x from a to b. We have to find the value of the antiderivative at the upper limit minus the value at the lower limit. How to evaluate it? You find the indefinite integral, then evaluate it using the value. Now, this was the basic way of finding integral a to b f of x dx. Now, how to do it by substitution? Evaluating definite integral by substitution. Normally, whenever we are doing indefinite integral by substitution, we have followed the method that first identify the substitution which to be done. After that, do the problem by normal way, that is by changing the integrand and the variable of integration with respect to the new variable. Do the integration and do the resubstitution. But here let us see what you have to do indefinite integral by substitution. We make the substitution for the function whose derivative also occurs in the integrand. This will come by practice or by doing so many problems you can identify. Upper and lower limit is changed as per the substitution. This we are going to do. Here it will help you a lot. Whenever you are not changing the upper limit and lower limit as per the substitution, what you have to do? You have to do the problem as it is, do the resubstitution, then apply the limit. In this case, there is no need for any resubstitution if you change the upper and lower limit. Then find the indefinite integral, then evaluate it using the new one. That's all. Okay, the indefinite integral may be in terms of x or it may be in terms of theta or t as per your substitution. Well, let us try some problems now. Integral 0 to 2, 2x upon 5x square plus 1. This can be done by taking integral 2x by 5x square plus 1 dx, do it totally, do the substitution, do the resubstitution, then substitute x is equal to 2 minus substitute x is equal to 0. That is okay. But now we can do like this also. We have identified that the differentiation of x square is inside, therefore u is x square, du is 2x dx. Now we will change the limit. What is the meaning of changing the limit? As I have changed it into u, I have to find the new values of u for x is equal to 0 and x is equal to 2. Very easily this can be obtained from the equation of substitution. U is equal to x square. Therefore, when x is equal to 0, u is 0. When x is 2, u is equal to 4. Therefore, from 0 to 2 will become 0 to 4. This you have to fix it in the beginning. Therefore, from 0 to 2, 2x upon 5x square plus 1 into dx will become integral 0 to 4. Because for u, it is from 0 to 4. U, t, whatever you have taken. For 2x dx is du, and in the denominator 5x square plus 1 is 5u plus 1. It is simply log of 5u plus 1 by 5 from 0 to 4. There is no need for resubstitution here, as I have changed the lower limit and the upper limit. For when I put 4, it will become log 5 into 4, 20 plus 1, 21. When I put 0, it will become log 1. All of you know that log 1 is 0. For final answer, 1 by 5 into log 21. Please see the technique. We are doing the substitution, changing the limits, the lower limit and the upper limit. Then we are doing the problem just like a problem of indefinite integral. Let us go for one more problem. Integral 0 to 4, 1 upon x plus root x. We have discussed several times. Whenever you don't know any substitution, whatever inside the square root, you take it as u square or t square or z square, whatever may be. For I am taking u square as x. 2u du will become dx and u will become root x. Okay. Now let us try to substitute now. The new limit, u square is equal to x. Therefore, when x is equal to 0, that u is 0 square, therefore 0. When x is equal to 4, u square will be square root of 4, 2. Some of you may ask me, sir, when I take square root, I am taking plus or minus 2. But remember, lower limit is 0, mean upper limit should be 2, it cannot be minus 2. Well, From 0 to 4 dx upon x plus root x. It will become integral 0 to 2. For dx I am putting 2u du. For x I am putting u square. For root x I am putting u. When I take u outside, it will get cancelled. The denominator will become simply u plus 1. Formula is very simple. It is log of u plus 1 from the interval 0 to 2. When I put 2, it will become log 3. When I put 0, it will become log 1. Therefore, the answer is 2 log 3. Let us continue. Again, this is a problem all of you know. Whenever cos and sin are coming, at least one of them will become a substitution. But here we have to do some changes. Sin square I am writing it as, sin cube I am writing it as sin square into sin. Sin square I am writing it as 1 minus cos square. Now, okay, now it is ready now for substitution. The differentiation of cos is inside. For let me take u as cos theta and du as minus sin theta d theta and minus du as sin theta d theta. Therefore, now I am taking the changing the limits also. When theta is equal to 0, u is equal to cos theta, cos 0, therefore 1. When theta is pi by 2, upper limit, u is equal to cos of pi by 2, which is equal to 0. Highly interesting. Here all of you may think that, sir, why the lower limit is less than the upper limit. Don't worry about it. There is a minus sign comes. There is a minus sign come. Because of that, there is a minus sign is coming. Anyway, for root cos theta is root u. 1 minus cos square theta is 1 minus u square. Sin theta d theta is minus du. I am taking the minus sign outside. I will keep it as it is. 1 to 0. Root u. When you bring it inside, root u into 1 is root u. Root u into u square is u power 2 plus 1 by 2, therefore 5 by 2. All of you know the integration of it. U power 1 by 2 is 2 by 3 into u power 3 by 2. U power 5 by 2 is u power 5 by 2 plus 5 by upon 5 by 2 plus 1, therefore it is minus 2 by 7. So I am putting the upper limit minus lower limit. Be careful. Here upper limit is 0, lower limit is 1. Therefore when you put 0, it will become 0 minus. If it is 1 means then u power 3 by 2 or u power 7 by 2 will become 1 only. 2 by 3 minus 2 by 7. When I take 21 as the LCM, it will become minus 8 by 27. Sorry, 21. Therefore, the answer is 8 upon 21. Don't worry about that lower limit and upper limit. Here after some time we are going to see one property. Whenever lower limit and upper limit are like this, that is the lower limit is a smaller number, upper limit is a bigger number, there will be a minus sign. Okay, we will see it later. As it is, I have just done it without doing anything. I am not changing the limits on top. Well, let us go to next problem. Already we have discussed it. Suppose if it is a problem of inverse trigonometric function, there is no need to do it directly by integration by parts. We can do it by substitution also. If it is sin inverse x, put x is equal to sin theta. For dx is equal to cos theta d theta. For theta is equal to sin inverse x. I am ready with that. Now I have to get the new limits. When x is equal to 0, theta is sin inverse 0, that is 0. When x is equal to 1, that is upper limit, theta is sin inverse 1, which is pi by 2. Therefore, integral 0 to 1 sin inverse x will become integral 0 to pi by 2 theta cos theta d theta. Now, this is a normal problem of integration by parts. Theta is there, cos theta is there. Therefore, you take u as theta, dv as cos theta d theta, du is d theta and v is sin theta. What we have to do now? We have to put it in the form uv minus integral v du. Normally we will put, but this is a definite integral problem where we have to apply the limit for uv also and integral v du also. Therefore, theta sin theta is uv minus integral v du sin theta d theta from 0 to pi by 2. Now, it is very simple. We have to put 0 is equal to pi by 2 minus sin pi by 2 minus 0 for the first bracket. For the second one, you know what is the integration of sin, it is minus cos. Therefore, I have put minus cos theta from 0 to pi by 2. Now, therefore, from the first one, sin pi by 2 is 1. Therefore, pi by 2 plus here minus minus into minus will become plus. Therefore, plus. When you apply the upper limit, it is cos pi by 2 minus cos 0. For cos 0 is 1. Therefore, pi by 2 minus 1 is the final answer. Here all of you can do the problem directly also by integration by parts by taking u as sin inverse x and dv as dx also. But here I have shown it by how it can be done using substitution, so that when you do the substitution, the problem will get reduced to integration by parts problem. and while you are doing the substitution, you can change the limit also so that it will be easy for you. No need for any resubstitution. Let us move on to the next question. Integral 0 to pi by 2 cos theta by 1 plus sine into 2 plus sine. By looking this problem, all of you know that. Let us try by doing a substitution, because differentiation of sine theta is inside. For x is equal to sine theta, dx is cos theta d theta, and when x is equal to 0, x is equal to sine 0 0. When theta is equal to pi by 2, x is sine pi by 2, which is 1. Therefore, the given problem 0 to pi by 2 cos theta d theta by 1 plus sine into 2 plus sine will become integral 0 to 1 upon 1 plus x into 2 plus x. This problem can be done very quickly by means of partial fraction. So let us put it as a by 1 plus x plus b by 2 plus x, because in the denominator you are having linear factors, non-repeated. For the first linear factor a upon 1 plus x, for the second linear factor b upon 2 plus x. Cross multiply, it will become 1 is equal to a into x plus 2 into b into x plus 1. We already discussed it in one of the videos. By selecting the value of x, we can eliminate a or we can eliminate b. Let me start with x is equal to minus 2, so that a will be coefficient of a will become 0. 1 is equal to a into 0 plus b into minus 2 plus 1. Therefore, b is equal to minus 1. Similarly, by taking x is equal to minus 1, I can make the coefficient of b becoming 0. Therefore, a is into 1. Therefore, a is equal to 1. Now, we have found the values of a and b. Let us put it now. 1 is equal to 1 into x plus 2 minus 1 into x plus 1. Check out whether LHS is equal to RHS. LHS is 1. RHS x plus 2 minus x minus 1. For 1 is equal to 1. Now put it in the integral sign now. 1 should be replaced by 1 into x plus 2 minus 1 into x plus 1 by the denominator. Split the integral into 2. If you integral into 2, that is first term by denominator minus second term by denominator will become 1 upon x plus 1. 2 plus x will get cancelled. 1 minus 1 upon x plus 2, because x plus 1 will get cancelled. Now when you do the integration, it will become log of x plus 1 first term minus log of x plus 2 the second term from 0 to 1. Now you put 1, it will become log 2 minus log 3. You put 0, it will become minus of log 1 minus log 2. Now it will become 2 log 2. Log 1 is 0, for you get 2 log 2 minus log 3. Here this problem is a problem of substitution, converting the problem into problem of partial fraction. But here we have converted the limits as per the new substitution, so that there is no need for any resubstitution. We are getting the answer directly. Success is dependent on efforts. All the best. Thank you.